this thing is off. You have to unmute. Okay. Fine. So that's okay.
Okay.
Just a minute. So this question, ball is dropped from a platform at t equal to 0 starting from rest, and after 6 seconds, second ball is thrown downwards from the same platform with velocity v. The two balls meet at t equal to 18 seconds. What is the value of v? So how do you proceed this problem?
I have no idea about it. That's why I was saying.
See, first you have to write what is there in the question. So there are two balls, right? So first let me call one of them as A. So for A, what is the thing given? U is 0, right?
Yes, sir.
And for B, U is
B.
V. Okay, and it's thrown after 6 seconds, right? So when
Both are not same level now, sir. A is thrown from raised platform.
sorry,
Both A and B are not at the same level now, sir. When they are dropped from that
no, they are the same level. You're not reading the question properly then.
High rise platform.
No. Same high rise platform. So after 6 seconds, another ball is thrown downwards from the same platform.
Okay.
So you have to read the question properly. Okay, from the same height. So when they are meeting, what is equal for both of them?
Velocity.
Why should it be same? What about the displacement?
The distance they have covered. No.
What about the displacements? How they are related?
Vertical distance.
See, ball A is dropped with U equal to 0. Okay, and ball B is dropped with U equal to V. And when they are meeting at some point, what is same for both of them?
Distance.
Yeah, so displacement is same, right? This is the displacement for the first one, this is the displacement for the second one. So both the displacement will match. Right?
Yes,
and what is displacement of A?
Half GT square.
And what about displacement of B?
B plus half GT square.
Vt plus half G. Actually, this T is same as or different?
Different.
So what should it be here for time?
T1 and T2.
It should be T minus 6. Because it's thrown down after 6 seconds. So for when the clock is saying 8 seconds, the body A would have traveled 8 seconds, but the body B would have traveled only 2 seconds. At 10 seconds, body A would have traveled 10 seconds, body B would have traveled 10 minus 6, 4 seconds. Is that clear? Okay, so the time that should be used for calculating the displacement of B should be T minus 6. Whatever is T for A, from that you will subtract 6 because it's going to travel for that much shorter time. Okay, because it's B's motion is starting after 6 seconds of A's motion. So A is taking longer time, and how much longer? By 6 seconds. So from this we can find T, right? Yeah, can you do this calculation? You have a pen and paper. G is 10. So just solve it.
The T dash here, B T dash T.
So it will be a quadratic equation. What is the value? Oh, sorry. T is given. T is 18. So it's simple then. You just have to put T equal to 18 and then find V. This is easier. So T is 18. (18 minus 6 is 12). Okay, just leave this thing. I'll come back to it later. Let's not waste time. Okay, this one. The bus is moving with the speed 10 meters per second on a straight road. A scooter is wishes to overtake the bus. And 100 seconds of the bus is 1 kilometer from the scooters with speed. Chase the bus. Okay, this is also similar to the previous one. First thing you have to draw the diagram. So this is again a 1D problem. So this is the bus which is moving at 10 meters per second. And the scooter is
So the previous 75 sir.
the previous one.
75
How did you get 75? This step is correct or not?
Which step, sir?
This one.
No, sir. I solved from the first equation. The blue one, half dt square plus d.
So see, this is the only equation to solve.
The t square, you didn't square it, sir. Half g into t minus 6 the whole square.
Okay. Right. Fine. So you got the answer?
Yes, sir. 75.
So can you check? Is it correct?
1 minute, I will take from this one. Option A, right only, sir. 75.
So T is 18. So 18 minus 6 is 12.
Five into 12 into 12.
No. Do you have the answers with you?
Yes, sir. Yes, sir. I checked it now only.
Why so much
75.
time? Huh?
75 only there, sir. Option A.
Okay, you got it, no?
Yes, sir.
Yeah, okay. Let's move to the next one. So this is also the similar problem only. So this is the scooter that's behind. So here time is t minus 100 seconds, and this distance is 1 kilometer. So when they are meeting, what will be saying?
Distance. If they start from the same point.
So when they are meeting, let me call this thing as A and bus as B. So what is the relation between AC and SB? SB minus 1 kilometer should be AC. Is that correct? When they are meeting? Is it clear?
No, I don't get it.
The scooter is starting behind, and the distance, the extra distance which it has to cover to catch up with the bus is 1 kilometer. Scooter is starting from behind. Okay, so the bus, so it will meet somewhere here. So when it meets somewhere here, the bus would have traveled this much, but the scooter would have traveled this plus this much. So AC will be, sorry, plus.
SB plus.
Yeah. And the time for scooter is t minus 100. Okay, and both are starting, both are uniform speed, right? Bus is moving and scooter is pushing to OT. Yes, the bus is with this watching. Okay, both are at equal speed. So obviously the scooter will travel at a higher constant speed. So this is of u into time t minus 100. That should be equal to SB, that is u of bus, the velocity of bus, into time t plus 1 kilometer. In terms of meter, it will be 1000 meters. And we have to find VA, right? Yes. So VB is 10. Okay. So the total time is 100 seconds. So both of them are traveling at 100 seconds. So I didn't see, both of them are starting at the same time. Okay. But the total time taken to catch up is 100 seconds. The concept is different. Both of them are starting at the same time. The difference is the initial distance, initial gap between them. So T is 100 seconds. So you got the answer? Into 100 plus 1000. So this is what? 2000. So this is 20. D, option D. Check the answer.
Oh,
Answer is what?
option B.
Is it correct?
Yes, sir.
Okay. So you got to know both are starting at the same time. The only difference is the extra distance. B is behind the bus. So it has to travel the extra distance of 1 kilometer. So this is the main step. And the time is same. Is it clear?
Yes, sir.
Okay. This one. Expression of particle values. Oh, this is very simple.
Based on graph, we have to answer.
You just have to find the velocity. How is velocity related to x?
Different.
Yeah. So V is dx by dt. It's a 1D problem. Okay, so you just have to take the derivative of this one, and derivative of exponent is same
minus
into minus alpha
alpha
plus b
into beta.
into beta. So
From this, how can I comment on it, whether it will increase with time or decrease with time? I don't know that.
velocity is independent of beta. That is not true. Drop to 0 when alpha equal to beta. So when alpha equal to beta, no, that's also not true. Goes on decreasing with time. With time, that's also not true. Goes on increasing with time. Goes on decreasing with time. Goes on increasing with time is correct, because see, as time increases, the second term is going to increase. Okay, and as time increases, the first term will decrease because it's minus alpha t and alpha is positive. Alpha beta are positive. So the second term is going to decrease and it's going to, and it's minus, it's getting subtracted. So second term minus the first term, the second term is keep on increasing, the first term is keeping on decreasing, and the first term is getting subtracted. So option D is the correct one. Can you check?
Option D only, right, sir?
Yeah,
But
so you understood, right?
no, sir, I didn't get it.
See, V is dx by dt and dx
Yes,
by
sir.
dt. So this expression is okay.
Yes, sir. From that, how do you say that it will
So the second term, as time increases, it will keep on increasing, right? E raised to the power positive quantity.
Yes, sir.
So, and the first term, if you just leave this negative sign, it will keep on decreasing, right?
Yes, sir.
But it is minus. So there are two terms, T1 plus T2. T2 keeps on increasing, right? And T1 keeps on decreasing, but it's actually, we are subtracting this quantity. So as time progresses, I am subtracting less and less quantity. Got it? If you just look at the first term only, it's minus of something, right? And that quantity is keeping on decreasing. Okay, and I'm subtracting lesser and lesser quantity as the time increases. So at the initial time, if T1 is say 2, I'll subtract T2 minus 2 from T2. At a later time, it will decrease, say minus 1.9 plus T2. So at a later time, we're subtracting lesser quantity, right? So if you combine these two, it will keep on increasing.
Yes, sir.
It will keep on increasing.
Yes, sir. Yes, sir. Yes, sir.
First thing, you should get the confidence is that the question is not difficult. Okay, it is not difficult, so you should see what you're not understanding. If you're clear in your thinking, you should be able to solve it. Okay, so you want to check the answer? You already checked, no? Right. Next one, a man throws a ball with same speed vertically upwards, one after another at a time interval of 2 seconds. What should be the speed of throw so that more than 2 balls are in the sky at any time? So this also you have to draw the figure properly. So he's throwing ball from this height. Okay. So when the ball is, when the first ball is somewhere here, he'll throw the second ball. He'll start throwing the second ball. Right? He's able to only throw 2 balls. Man throws balls with same speed vertically upwards one after another at an interval of 2 seconds, what should be the speed of throw so that more than 2 balls are in the sky at same time? More than 2 balls are in the sky at any time. So let's consider just 2 balls at the sky. So what should happen is, so okay, this is the first ball. Okay, let the first ball be here, not that way. So when the first ball is trying to come to his hand, the second ball should be somewhere here, and the third ball he just throwing. Okay, only then 2 balls will be there at any time. Is it clear? Yes.
One second, sir. The question is written.
Question is clear. The man is throwing ball vertically upwards. What should be the speed of throw so that more than 2 balls are in the sky at the same time? So more than 2 balls means then it should be at least 3, no? Okay. Then let me
But they
take,
didn't answer that one, sir.
so let me take one more then. So let the second ball be here, and let this be the third ball, and let the, so when the first ball is coming down to his hand level, he should have thrown the fourth ball upwards. So only then 3 balls will be in the sky. Is it clear?
Yes, sir.
More than 2 balls, so let us assume 3 balls. Okay, so and all of them are thrown with same this thing. So let the time taken for the first ball to go up and come down, let it be capital T. Okay, so in this interval of capital T, you have thrown first ball, second ball, third ball, fourth ball. So 3. So the time interval between the 2 throws should be T by 3. The first ball let him throw at the time T. The second ball he throw at the time T by 3. The third ball he throw at the time 2T by 3. And the fourth ball he will throw at the time T when the first ball has come down. Okay, so now we can solve the problem. So time is capital T. So the height, that is, so the time taken to go from here to here, that is half the distance. It's capital T by 2. Okay, so height okay, this is the idea. So I'll come back to this. Let's not waste time. A rubber ball is dropped from a height of 5 meters on a plane. On bouncing, it rises to a height of ball loses the velocity. Okay, this is very simple. You can solve this question by 2 methods. One is kinematics, another one is energy conservation. Okay.
Okay.
So since we just have to get the answer, you can solve by energy conservation because that'll be faster. So how do you solve? the energy at the bottom point is half m u square, right? At the topmost point, the energy will be mg into h, because kinetic energy will be 0. Is that right?
So kinematics about
See, in the exam, we just want to tick the answer. It does not matter whether you solve by kinematics and energy conservation. We just have to get the right answer. So this will be faster. We'll first do by this. Okay. And this second ball is the second time it will lose some velocity. So let it be u2 square equal to mg h2 in the second case. And what is h2? 1.8, right? H is 5. So if you divide these two, you get u by u2 square equal to h by h2, that is 5 by 1.8. So this is 50 by 18, that is 25 by 9. So u by u2 equal to 5 by 3. So u2 is the ball loses its velocity by a factor. So 3 by 5. The correct answer is A.
Okay.
If you solve by kinematic equation, will be is equal to ut minus half gt square. Okay, it's 5 meters, right? So in 5 meters, the velocity is becoming 0. So you can use this one, v equal to u minus gt. You can use this one, h equal to vt minus half at square. V is 0. No. No, energy projection is much simpler.
Yes, sir.
Okay, right. Okay, this one 41, your body is dropped from a tower and falls to 40 meters during last 2 seconds of its fall. Okay, this is a simple problem. You should be knowing. Try to solve it. Solve this one. By now, we should be able to solve this one. So let it come and touch this ground at t seconds. So at t minus 2 seconds, this distance is 40 meters. So it is drop means u is 0. Okay, so how do you solve this problem? It's very simple. Can you relate the displacement at time t and the displacement at time t minus 2?
Yes, sir. 40 meters.
So displacement at time t 40 meters, right? And displacement at time t is half g t square, and this is half g t minus 2 square plus 40. So now we have to find height of the tower. So once you get t, height of the tower is this one, right? Height of the tower is same as the displacement at time capital T. capital T is the time taken to go from here to here. So half gt square, oh, it's cancelling. Okay.
Time 2 seconds.
So half gt square, half gt square will cancel. And then half g minus 2t. So minus t plus 4 plus 40. So basically you will get capital T, or this is 0. Is it clear? Here half gt square will come, that will cancel, and then half g minus 4t plus 4. Okay, so 4 will cancel, g is 10, 4 will cancel, so it will be minus t plus 1, 4 will cancel, 10 will cancel, so it will become 1.
T is equal to 6 seconds.
So t is 1 plus 2, 3. So height is half g into t square is 9. So it should be 45. Option B. Is it correct? Answer is correct.
Yes, sir, option B.
So you understood, right? Capital T is the time taken from the top point to the ground. So at t minus 2, the displacement at t and t minus 2 are related by displacement at t minus 2 plus 40 should be displacement at t. And the height is same as the displacement from here to here. So the height is same as finding half gt square. So first we can find capital T, the time of flight, which is 3 seconds. From that we can get half gt square as 45. Okay. So this one, okay, I'll come back to that later. So let's move the today's class. So much time has gone.